Imagine a system that learns from its mistakes, a system that can see, hear, and even create art without being human. What if I told you that the secret behind almost every modern AI, from ChatGPT to self-driving cars, comes down to something inspired by your own brain? Today, we're diving into neural networks, the invisible architecture powering the AI revolution. And by the end of this video, you'll understand exactly how they work, even if you've never written a single line of code. It all started with a question. Can we teach a machine to think like a brain? Your brain is made up of about 86 billion neurons, tiny cells that send signals to each other through electrical impulses. When one neuron activates, it triggers others, forming vast patterns that let you recognize faces, understand language, and remember experiences. Scientists thought, what if we could simulate that process with math? That's how the first artificial neural networks were born. Digital neurons connected in layers, passing signals, just like in the human brain. And surprisingly, it worked. Let's make this simple. Imagine you want to teach an AI to recognize a cat. You show it thousands of pictures: cats, dogs, cars, everything. Each image is turned into numbers, pixels, colors, shapes. These numbers enter the first layer of the neural net, called the input layer. Then, they pass through several hidden layers, where each neuron does a small calculation. Each neuron decides how strongly to react, based on something called a weight. These weights adjust every time the network makes a mistake, just like how your brain learns from feedback. Finally, the last layer gives an output, something like 90% sure this is a cat. The more examples it sees, the smarter it gets. That process is called training. But here's the twist. No human tells it how to recognize a cat. It figures that out on its own. Inside those hidden layers, something amazing happens. The first layer might learn to detect edges or colors. The next layer combines those edges into shapes: eyes, ears, whiskers. And deeper layers? They start understanding concepts, like this fluffy shape with two eyes and pointy ears equals cat. The neural net builds knowledge layer by layer, transforming simple information into complex understanding. That's how it can see faces, translate languages, or even write poetry. In short, neural nets don't just follow instructions, they discover patterns in chaos. But wait, if they're discovering patterns, do they actually understand what they're seeing? That's where things get strange. Neural networks don't think the way we do. They don't have emotions, intentions, or awareness. But in some ways, they simulate understanding frighteningly well. For example, when you ask ChatGPT a question, it doesn't know the answer. It predicts the next word based on patterns it has learned from billions of examples. And yet, the result feels intelligent. So are neural nets truly smart? Or are they just mirrors, reflecting patterns of human intelligence back at us? That's a question even AI researchers are still debating. Because sometimes, even the scientists who build these systems can't fully explain why they make certain decisions. Neural networks are now the foundation of modern AI. They power image recognition, voice assistants, translation apps, music generators, self-driving cars, and even tools that design new medicines. Every smart technology you see today likely runs on some form of neural net. And as computing power grows, these networks are getting deeper, faster, and more capable. That's what we call deep learning. Some neural nets now have billions, even trillions, of connections, each one a tiny spark in a massive digital brain. It's like humanity has built a second nervous system, not in our bodies, but in our machines. So where does this lead us? As neural networks evolve, they're starting to blur the line between human and artificial intelligence. We're already seeing AI that can imagine, reason, and create traits once thought uniquely human. But the real question isn't how they work anymore. It's what we'll do with them. Will neural networks amplify our creativity or replace it? Will they make us smarter or more dependent? The answer depends on how we, as humans, decide to train our own neural networks. Neural networks might sound complex, but they're really just digital reflections of the most powerful system we already know, the human brain. If you enjoyed learning how machines learn, hit that like button and subscribe to AI Horizon Guide, because next time we'll explore how AI actually sees the world, and it's wilder than you think. This is AI Horizon Guide, the future decoded.